Salutations to you out there. You're welcome to my YouTube channel. We have another question to solve today. And the question we are solving today is on application of the law of indices. Let's go solving the question on the board. We are giving solve for y in the equation. This is the equation, and we are expected to apply the law of indices to solve this particular question. Looking at this question, I can see a base and a power, a base and a power, a base and a power. I have 10 here, I have 5 here, I have 4 here. I can simplify this 10 in terms of 2 and 5. 5 is already simplified. I can also simplify this 4 in terms of 2. Going by that, I am going to have 10 is 2 times 5 raised to the power of y times 5. I have here 2y minus 2. Then times this 4 is 2 raised to power 2 into y minus 1. And everything equals 1. That is the first thing I'm going to do. Law of indices. When you have something of this nature, it shows that everything inside this bracket will be raised to this power. So if I simplify this bracket further, I will have 2 raised to power y times 5 raised to power y. Then simplify this one further, we have 5, 2 raised to power y times 5 raised to power minus 2. Then here, so I'm going to have times 2 raised to power 2y times 2 raised to power, if you open the bracket, this one will give us minus 2 is equal to 1. Here, I have something that 2y minus, that is why you have minus 2 here. So from here, I can easily collect the like terms here. If I should collect like terms here, I will have something like this. 2 raised to power y, any 2 there again, times 2 raised to power 2y, times 2 raised to power minus 2. The 2 are together now. So times 5 raised to power y. The 5 are together. I have 2y here times 5 minus 2. Everything equals 1. So what would I do here? I am going to apply 2 laws here. The first law I'm going to apply, I have 5. I have a m times a n. This will give us a m plus n. I have another law here, a raised to power minus 2. It means I'm going to have 1 all over a 2. I will apply these 2 laws to both 2 and 5. So if I should do that, I will have 2y plus 2y, everything all over 2 raised to power 2. And 2 raised to power 2 is 4. So I will put 4 here. Times, this one is 5y plus 2y. Everything all over 5 raised to power 2, which is equal to 25. I have 25 here. Everything is now equal to y. Simplifying further from there, if I should simplify further from there, what will I have? I will have something of this nature. Y plus 2y will give us 3y. That means I am going to have 2, 3y all over 4 times 5, 3y all over 25 is now equal to 1. But there's something we need to consider here. You will notice that since we have multiplication here, that means the fraction can be multiplied by this other fraction. And in that process, the numerator can multiply numerator, while denominator can also multiply denominator. So if I should do that, I will have 2, 3y times 5, 3y. Everything all over 4 times 25, which is now equal to 1. So from here now, you will observe that both two here, if you consider this term here, I have 2 raised to power 3y. If you also consider this term here, I also have 5 raised to power 3y. That means I can simplify them further, as in the power 3y is common to the two of them. So if I should observe that, that means I'm going to have 2 times 5 raised to power 3y is now equal. Here, I can cross multiply here. If I cross multiply here, that means 4 times 25 return to 100. And I can now cross multiply this. That means I will have 100 there. So from there, I will have 2 times 5 is 10 raised to power 3y. Everything is now equal to, I can also simplify this 100 in terms of 10. And 100 is equal to 10 raised to power 2. That means I will have here 10 raised to power 2. So when you have something of this nature and the base are the same, that means the base will cancel. This will cancel. We are now left with 3y is equal to 2. So I can divide both sides by 3. So my y now will now be equal to 2 all over 3. We are going to stop here for now. I will take it off from here next time. God bless you. God bless me. We move